Hi everyone, welcome to Numeriq Learning. In today's video, let us solve Chapter 2 Polynomials exercise problems from NCERT Exemplar. So the first question for the day is, if one of the zeros of the quadratic polynomial k minus 1 into x square plus kx plus 1 is minus 3, find the value of k. You are given three options. We need to find the value of k in this polynomial. So what are we given? We are given one of the zeros is nothing but we have minus 3. First of all, let us write what is the polynomial p of x. So let the polynomial p of x be k minus 1 into x square plus kx plus 1. This is the given polynomial. And we are given one of the zeros of this p of x is minus 3. What does that mean? If you substitute in place of x, if you put minus 3, then the value of the polynomial becomes 0. That is what it means when the question says that one of the zeros of the polynomial is minus 3. What does it mean? At x equal to minus 3, the value of the polynomial is 0. That is why it's called a 0. Now let us substitute in place of x, we will substitute minus 3 and let us find the value of k. So k minus 1 multiplied by in place of x minus 3. So minus 3 the whole square plus k multiplied by minus 3 plus 1 is equal to 0. So k minus 1 multiplied by minus 3 into minus 3 is plus 9. Minus 3k plus 1 is equal to 0. So multiply 9 with k and 9 with minus 1. So 9 into k is 9k minus 9 minus 3k plus 1 equal to 0. So 9k minus 3k is nothing but 6k. Minus 9 plus 1 is minus 8 is equal to 0. So what are you getting here? 6k equal to 8 or k is equal to 8 by 6. So 2 3s are 6, 2 4s are 8. So what is the value of k? 4 by 3. So the correct answer is A, 4 by 3. Okay. Please pause the video and do it along with me, because one very important thing that every student who is right now starting class 10th is, with respect to mathematics, please make sure you do all the exercise problems of your NCERT and Exemplar, which will give you a very, very good practice. Level 1, the first set of practice that you need conceptually in all the topics within a particular chapter. So please make sure you actually do and see. Please solve each and every question in your NCERT and Exemplar before you start with respect to any other reference book that you have. Right? So here the value of k is 4 by 3. Now let's move on to the next question. The question is, a quadratic polynomial whose zeros are minus 3 and 4 is, you have to find out which one. So whenever you are given the zeros, we can find out the sum of the zeros and we can find out the product of the zeros, right? Because if we have the sum of the zeros and product of the zeros, we know the formula. What is the formula? K multiplied by x square minus sum of the zeros into x plus product of the zeros. So this is your quadratic polynomial. This is your quadratic polynomial which they are asking. Let us find what is the sum of the zeros. So sum of your zeros will be, just add it up. Okay, sum of the zeros. So it's minus 3 plus 4. So what is 4 minus 3? It is just 1. Okay, so this is your S. Let's find the product of the zeros, which is nothing but minus 3 multiplied by 4, which will give you minus 12. Now let us substitute. In place of S, we will substitute 1, and in place of P, which is the product of the 0, we will substitute minus 12. Okay, so what does the polynomial become? It is nothing but k multiplied by x square minus 1 into x plus of minus 12. So I am going to plus into minus is minus. So I am going to write minus 12. Or I'll write a plus and then minus 12, and in the next step I'll make it. So k multiplied by x square minus x minus 12. This is your required polynomial. Right? So when k is equal to 1, you will have x square. But you do not see this as an option, right? X square minus x minus 12. You don't have that. So let us divide throughout by 2. So what do you get? So suppose if k is 1, the polynomial will be x square minus x minus 12. Divide throughout by 2. So what do you get? X square by 2 minus x by 2 minus 12 by 2, which is 6. So this is your required answer. And what is the option? The option is option C. Okay, x square by 2 minus x by 2 minus 6. So always make sure when you have options given, you have to match, right? So the x term also has a negative, the constant also has a negative sign. So that is applicable only in option C. Right? So I hope you understood. Let me know if you have any doubts at all in the comments. And I am also doing a 20 minutes daily practice series. So do check out the playlist Do Math with Me, wherein I solve a set of 5 to 6 questions for a time period of 20 minutes, so that all of you get into the habit of solving problems with me just for 20 minutes a day. Right? So, and also I am hosting a live YouTube session wherein you can connect with me every Sunday 6 p.m. and we will solve important MCQs of all the chapters. So this Sunday, that is April 5, evening 6 p.m. do join me live on YouTube, and we will be doing important MCQ questions from the chapter Polynomials. Right? Do make a note of it, and let's see you all there. Now let's move on to the third question. If the zeros of the quadratic polynomial x square plus a plus 1 into x plus b are 2 and minus 3, then you have to find the values of a and b. Again, let us do it. You are given your polynomial p of x is given to you. X square plus a plus 1 into x plus b. You are given the zeros, right? Now, let's find out the sum of the zeros. Now that you know, so what is the sum of the zeros? Sum of the zeros is nothing but, what is the formula? Alpha plus beta is equal to minus b by a. So what is minus b by a? Minus of a plus 1 divided by 1. Right? Now, suppose if the zeros are already given 2 and minus 3, let us substitute that. So 2 plus of minus 3 should be equal to minus of a plus 1. What is 2 minus 3? It is minus 1 is equal to minus of a plus 1, right? So minus and minus gets cancelled. A will be equal to 1 minus 1, which is 0. So what is the value of a that we are getting? A is nothing but 0. Okay, now with this itself you would have found the answer is option D. But let us do the other part as well. What is the product of the zeros? So let me do it here. With respect to the product of zeros, we know the formula alpha beta is equal to C by A. What is alpha into beta? Just the product of 2 and minus 3, right? So 2 into minus 3 is equal to C by A. What is C? C is nothing but your B, right? A is nothing but your 1. So it is just B. So B is equal to 3 into minus 3 into 2, which is minus 6. So therefore the given answer is A is 0 and your B is nothing but minus 6. So this is your final answer. So which is option D. Okay, very easy. All you have to remember is whenever you are given p of x, first thing is you can pick up the coefficients also. That is, a is 1 here, b is nothing but a plus 1, and your c is nothing but your b. And then use the formula. Sum of the zeros is equal to alpha plus beta equal to minus b by a, and the product of the zero is nothing but c by a. Alpha beta equal to c by a. If these two formulas you know, you can do a lot of things with respect to finding the quadratic polynomial, or finding the zeros, or kind of finding any unknowns like k, which are a part of the polynomial. You can do n number of things if you know zeros, or if you know the sum of zeros. Right? Let's move on to the next question. Fourth one. The number of polynomials that have zeros as -2 and 5 is, so again, let us take the sum of the zeros first. Sum of zeros. You are given zeros, that is alpha is -2, beta is 5. This is given to you. So what is the sum of zeros? -2 plus 5, which is nothing but 3. And what is the product of the zeros? Product of zeros is nothing but, just find the product, -2 multiplied by 5, which is nothing but -10. Now the quadratic polynomial will be k multiplied by x square minus sx plus p. So k multiplied by x square, s is nothing but 3x, and p is nothing but -10. So -10. Now for any value of k, right, suppose if I write k equal to 1, when k equal to 1, the required polynomial will be, you are asked to find the polynomial that have the zeros as -2 and 5. So we found out the sum, we found out the product of the zeros, and using sum and product we were able to generally find out the basic required quadratic polynomial using this formula, right? Now for any k equal to 1, the quadratic polynomial will be x square minus 3x minus 10. Okay. For k equal to 2, suppose k equal to 2, what will it be? 2x square minus 6x minus 20. Correct? Like this, there can be infinite number of polynomials depending on the value of k that can have the zeros as -2 and 5. So based on the value of k, the number of polynomials will be infinite in number, right? So the answer for this question is more than 3. You cannot restrict always, for there can be infinite number of polynomials that can have zeros for any two numbers, not necessarily the given numbers -2 and 5. For any set of zeros, it will never be just one polynomial that has a given numbers as zeros. Okay, you can have infinite number of polynomials with a specific set of zeros that are alpha and beta, that is denoted by alpha and beta. So please remember it. Even if there was an option called infinity, you have to mark it as infinity. So that's your answer for the fourth question. So right now we are doing Exemplar 2.1 question number 4. Let's move on to the next question. I hope you understood. The zeros of the quadratic polynomial x square plus 99x plus 127. The zeros of the polynomial given as x square plus 99x plus 127 are both positive, both negative, one positive, one negative, and both are equal. Let us find it out. Suppose the given polynomial x square plus 99x plus 127 is equal to 0. So, what will be the sum of the zero? Sum of the zeros, which is nothing but your alpha plus beta, will be minus b by a. What is b here? 99, right? The coefficient of x. So minus 99 divided by 1, because your a is 1. So I'm just going to write minus 99. Product of the zeros alpha into beta will be C by A. What is C? 127 by A is 1. So 127. Now, if you have there are two scenarios which are possible. First scenario is if you have alpha plus beta is nothing but minus 99. You can have two scenarios. Either alpha or your beta, they are negative. This is one scenario possible. Or if the sum has to be negative, then I can say both alpha and beta are negative, because if I have, say, minus 100 plus 1, right? Minus 100 plus 1, again beta is positive, alpha is negative, right? Or 1 minus 100, the answer is going to be minus 99. Or if I have, that's the first case, either alpha or beta are negative. Or if I have minus 90 minus 9, what is going to be the answer? When both alpha and beta are negative, it is going to be negative. So both alpha and beta are negative. So these are the two scenarios that are possible for the sum to be minus 99. Now let us talk about the product. If alpha multiplied by beta has to be 127, again, there are cases, it could be that alpha and beta are both positive because the product is positive, or even if alpha and beta both are negative, negative into negative is positive. So alpha and beta are negative, both negative. That could also be possible, right? In order to make the product positive, either both are positive or both are negative. Now, among these two scenarios, which is the one condition which is common? See here, both alpha and beta are negative, then your sum will be negative. If both alpha and beta are negative in the second scenario, also the product would be positive. So the correct answer is both alpha and beta are negative. So it's option B, which is the correct answer. So in such questions, you will have to actually take an example and think and do it. So let's see this question. The zeros of the quadratic polynomial x square plus kx plus k, where k is not equal to 0. So about the zeros of this polynomial, the options are: the zeros cannot be both positive, both cannot be negative, they are always unequal, and they are always equal. Okay. So here, if k is not equal to 0, the only possibility is k can either be less than 0 or k will be greater than 0. So let's go ahead and do that. So the given polynomial is x square plus kx plus k. So if it is not equal to 0, k will either be less than 0 or k will be greater than 0, right? If k is less than 0, that means k is negative, then what will be your polynomial? X square minus kx minus k. This will be your polynomial. And if it is k is greater than 0, means k is positive, then the polynomial is x square plus kx plus k, right? These are the only two possibilities. What will be the sum of 0? Alpha plus beta will be equal to minus b by a. So minus of minus k by 1, which is nothing but your just k. And alpha multiplied by beta, product of the zeros, will be c by a. What is c? It is minus k by 1, which is minus k. In the other scenario, wherein k is greater than 0, the sum of the zeros alpha plus beta is equal to minus b by a, which is nothing but minus k. And the product of the zeros will be c by a, which is nothing but just k. Now, in this scenario, right, wherein the sum has to be positive k and the product will be negative k. What does it mean? Alpha, the very first observation is, say, alpha is a bigger number and beta is a smaller number. Okay, so if beta is negative, so bigger number minus smaller number will be a positive number, right? And that same bigger number multiplied by negative of a smaller number will give you negative. So what does it mean? Alpha and beta, they are of opposite signs. They are of opposite sign. If one is positive, the other one is negative, right? So this is one observation. Okay, so if alpha is positive, then your beta will be negative. And if your alpha is negative, then beta will be positive. Okay, so this is the observation. Now let us check when k is greater than 0. Okay, when is the scenario wherein alpha plus beta is minus k and alpha beta is k? That means both alpha and beta are negative, right? Only then the sum will be negative, and if the product of two negative numbers, it is going to be positive. So in this case, you will see that alpha and beta are both negative. Okay, now looking at all the options, okay, the zeros, what do we see here? Alpha and beta are of opposite sign in one of the scenario, and then alpha and beta are both negative. So which of them is the possibility? So it means the zeros of the chord, it cannot be both positive. That's the correct answer. Okay, either one will be positive or one will be negative is one scenario, or both will be negative. Okay, so the answer for this question is A, option A, right? Okay, so the zeros cannot be both positive. In none of the scenarios you are seeing that both are positive, right? Either both are negative or they are of opposite signs. Okay, either both are negative or they are both of opposite signs. So it cannot be both positive. So this is the answer. Let's move on to the seventh question. If the zeros of the quadratic polynomial ax square plus bx plus c, where c is not equal to 0 are equal, then C and A have opposite signs, C and B have opposite signs, C and A have same, and C and B have same signs. So whenever you are given that the zeros or a polynomial p of x have equal zeros or equal roots, right? There is something that you have to remember. So whenever you are given that p of x, they have equal roots or zeros. That means your discriminant capital D is equal to 0. And what is the value for a discriminant? It's b square minus 4ac is equal to 0. Okay, so in our scenario, what is b square equal to? So you'll have b square equal to 4ac, right? ac will go to the other end. What is ac then? ac will be b square divided by 4. Right? What is b square? Any number square is always going to be positive. 4 is also positive. So positive by positive, a and c will also be a positive number. Right? So if a and c are positive, what do you mean by that? A and c have the same sign. A and c have the same sign. Okay. So the option is C and A have the same. So this is the option C is the correct answer. Right? Okay. So the only thing that you have to remember, if in case if the zeros are equal, then you have to remember that discriminant value, that is b square minus d is equal to b square minus 4ac. So that discriminant is 0. Right? Okay. So that's all you have to remember. Whenever the zeros are equal, the discriminant value d is equal to b square minus 4ac. A, B and C, you can get it from here, right? A is your coefficient of x square, coefficient of x and your constant term. Okay, let's move on to the next question. If one of the zeros of a quadratic polynomial of the form x square plus ax plus b is the negative of the other, then it has no linear term and a constant term negative, has no linear term, constant term is positive, can have a linear term but the constant term is negative, can have a linear term but the constant term is positive. So let us do that. What is given is if one of the zeros of the quadratic polynomial is the negative of the other. Suppose if one of the zero is equal to alpha, then your other zero will be minus alpha. Okay. And the standard form of a quadratic polynomial is ax square plus bx plus c. Okay. Always remember this first term, that is x square term, this is what is called as the quadratic term. It is called the quadratic term. Okay. This bx, because it is the coefficient of x and the degree of x is 1. This is what is called a linear term. And c is nothing but it's called a constant term. Okay. Now, we have taken, according to the question, if one of the zero is the negative of the other, that means alpha, the other one is negative of alpha, then what is the quadratic polynomial? The formula is k multiplied by x square minus the sum of zeros into x plus product of the zeros. This is the formula. K multiplied by x square minus just add these two zeros. So minus alpha plus alpha into x plus the product of the zeros, alpha into minus alpha. Okay, so k minus alpha plus alpha will get cancelled. So you'll have x square minus 0. So this entire second term becomes 0. And then you have alpha multiplied by minus alpha, which is minus alpha square. Okay. So what is this x square? As I told you, this is your quadratic term. Okay. So whenever you have one of the zero is alpha, the other one is the negative of that zero, then what happens is we do have the quadratic term. What is this alpha here? What is this alpha square? Do you have any x term? No. Alpha square is a constant term. So the constant term is there, but what is the sign? It is a negative sign. Okay, so you can say that constant term is present, however, but it is negative. But it is negative. So what will be our answer here? Okay, and does it have any linear term? Does it have any x term? No x term. So look at the first option. It has no linear term and the constant term is negative. Okay, so the option would be option A. Okay, the first option. This is the correct option, option A. Okay, I hope you understood. So whenever you do such questions, just be careful about what the question is giving you and understand the question, and please try to do it, and you have to find an inference. You have to observe how the results are looking like. And based on that, you'll have to read all the options and choose the correct one. Let's move on to the next question. Which of the following is not the graph of a quadratic polynomial? So the minute you see, okay, whenever you're given the graph of a quadratic polynomial, see how many times the graph is cutting or touching your x-axis. In this case, it does not touch. So, if it does not touch, the number of zeros is 0. Number of zeros of this p of x is going to be 0, right? Here, it touches it at just 1 point. Again, the number of zeros is 1. Here it touches it at 2 points. So the number of 0 is 2. Always remember, so whenever you have a quadratic polynomial of the form ax square plus bx plus c, this quadratic polynomial will have a maximum of 2 zeros because the degree is 2. It can have no zeros, it can have 1 0, or it can have 2 zeros. It can never go beyond 2. So the first, second and third are quadratic polynomials. But what are you asked? Which of the following is not the graph of a quad? So here if you see the last graph, the number of points where it cuts your x-axis is 3 points. So which means the number of zeros here is 3. And if it is 3, it is never a quadratic polynomial. So the option is, it's the last answer. The last graph is not the graph of a quadratic polynomial because the number of zeros is greater than 2. So it is not a quadratic polynomial. Okay, I hope you understood. Do make a note of this, and we will be solving the exercise 2.2 in the coming videos, and make sure always make it a practice to solve all the exemplar questions and the solved examples of both the books. And do mark in your calendars to join me at 6 p.m. every Sunday in my channel at 6 p.m. for a live session wherein we will be solving MCQ questions. So the coming Sunday we will be doing MCQ questions from the chapter Polynomials. So do not forget, do join, let's learn. This is exercise 2.2. We covered 2.1 in the previous video. Please do check out if you haven't. Let's get started with today's exercise question. Question number 1. Can the quadratic polynomial x square plus kx plus k have equal zeros for some odd integer k greater than 1 is the question. So whenever you have got equal roots, right, whenever for any polynomial you have got equal zeros or equal roots, the thing that you have to remember is that the discriminant is always 0. D is always 0. So what is the value for, how do you calculate D? Discriminant b square minus 4ac. Let me write here, discriminant is equal to 0. And what is b here? So from the given polynomial, you have your a is 1, the coefficient of x square, your b, coefficient of x is k, and your c is also k. So what is b square? K square minus 4 into a is 1, c is k, equal to 0. So k square minus 4k equal to 0. Take k common out, so you'll be getting k minus 4 equal to 0. So either k is equal to 0 or k minus 4 equal to 0, which means k is equal to 4. What are they asking? Can this quadratic polynomial have equal zeros for some odd integer k greater than 0. So one of it is k equal to 0, but for a value which is k greater than 0, k is an even integer. It's not an odd integer. So this particular question would say no, right? It cannot have. So the answer is no. This quadratic polynomial cannot have an odd integer. For when it has equal roots, it cannot have, k cannot be a number greater than 1 and an odd integer. So the answer is no. Right? You have to write it. No, the given quadratic polynomial cannot have an odd integer for equal roots. So that should be your answer. I hope you understood, because you are getting an even integer for k greater than 1. This is even. Let's move on to the second question. You will be given, say there are 4 questions under this. Are the following statements true or false? Justify your answer. The first question is, if the zeros of a quadratic polynomial ax square plus bx plus c, can the zeros are both, if the zeros are both positive, then a, b and c all have the same sign, right? Now let us take with an example. So what is given? That if the zeros are both positive, right? So let the zeros, let's take any 2 positive integers. Okay, let the zeros be, say 3 and 5 respectively. That means Let alpha be 3 and your beta be 5. How will you write a quadratic polynomial if you know the zeros? Your k multiplied by x square minus the sum of zeros plus p. So k multiplied by x square minus what will be the sum? 3 plus 5. 8x plus 3 into 5, which is 15. Okay. So for k equal to 1, when you have your k is equal to 1, the quadratic polynomial is x square minus 8x plus 15. Here what is a? A is 1, right? A is 1, which is a is greater than 0. What about b here? B is minus 8. So b is less than 0 or b is negative. And what about c? C is a positive value. So c is also greater than 0. However, not a, b and c. All the three are not of the same sign. B is of a negative sign. Right? A, B and C are not of the same sign. So what is the statement? The statement says if the zeros of the given quadratic polynomial are both positive, then A, B, C all have the same sign. No, it is not, right? A, B and C do not have the same sign. So, is it true or false? It is false. Okay. Let's move on to the second question. If the graph of a polynomial intersects the x-axis at only one point, it cannot be a quadratic polynomial. So, suppose, okay, you have got, there are two same zeros, okay, you have a graph and both the zeros, okay, there are two zeros, alpha and beta are both equal. So, if two zeros, that is alpha and beta, are both the same points, right, then both would be, the two points, the two intersecting points will be coinciding and they'll become a single point, right? So, whenever the two zeros of the quadratic polynomial are equal, then both the points will be coinciding and it will become one point. Am I right? So, here what they say is it cannot be a quadratic polynomial. But so this is nothing but it's false. Why is it false? Because there is a possibility that both the zeros alpha and beta could be same or could be equal. In that case, both will be coinciding and becoming a single point. So it is possible. Okay. Next one. If the graph of if a graph of a polynomial intersects the x-axis at exactly 2 points, it need not be a quadratic polynomial. Is it true or false? See, whenever the graph of a polynomial, it intersects the 2 points, it intersects the x-axis at exactly 2 points, it need not be a quadratic polynomial. So it is true. It may be a quadratic polynomial, it may not be a quadratic polynomial. The answer is true. Okay, why? Because so a polynomial of degree more than 2 is also possible, which intersects the x-axis at exactly 2 points. Suppose if it has got say 2 real roots and the other roots are all imaginary roots, then there is a possibility that it may be a quadratic polynomial, it need not be also a quadratic polynomial. So, if the graph intersects the x-axis at exactly 2 points, it may or may not be a quadratic. Now, suppose here if you have a graph like this graph also intersects the x-axis at exactly 2 points. Do you say this is a, can you say this is a quadratic polynomial? No, you cannot say. Okay, so it may be, it may not be a quadratic polynomial. So the answer is true because it says it need not be a quadratic polynomial. So it is correct. The statement is true. So I hope you are getting it. Let's move on to the next question. The only value of k for which the quadratic polynomial kx square plus x plus k has equal roots is 1 by 2. Let's write the given polynomial. P of x is nothing but kx square plus x plus k. What is a here? A is k, b is 1, and C is also K. As I told you, whenever you are dealing with the polynomial with equal roots, your discriminant is 0, which means b square minus 4ac is equal to 0. What is b square? 1 square minus 4 into a is nothing but k, c is also k, equal to 0. Right? So 1 minus 4k square equal to 0, or 4k square will go to the other end, 4k square equal to 1, or k square is nothing but 1 by 4, or I can write k is equal to plus or minus root of 1 by 4, or nothing but plus or minus 1 by 2. So k can be two values, right? It can either be plus 1 by 2 or it can be minus 1 by 2. Okay. So for both these values of k, that is 1 by 2 and minus 1 by 2, the given quadratic polynomial has got equal zeros. So this statement that it says that the only value of k for which the quadratic polynomial has equal roots is only 1 by 2. No, it is false. This statement is false because it is not just plus 1 by 2. You can also have minus 1 by 2, k as minus 1 by 2, for which the polynomial can have equal zeros or equal roots. Okay, so this statement is false. I hope you understood, and these are the only questions which are there in your exercise 2.2. And there's one more announcement that I would like to make, that every Sunday 6 p.m. please do join me on a live session wherein we will be solving MCQ questions, all multiple choice questions from previous year's questions. And this week, for the coming week, we'll be solving questions from the chapter Polynomials. So do keep your reminders and definitely do join. It will definitely be an interactive session and you will definitely learn a lot. The time is 6 to 7 p.m. And this video, if you like it, please do consider subscribing. Do share it with your friends. We will be doing the Do Math with Me. It's day 12 today and we will be solving problems from the chapter Polynomials. So far, we have been solving multiple problems related to real numbers, your chapter 1 and polynomials. So today is day 12. Please take your notebook and pause the video. Do these problems with me because each and every problem has been handpicked from the previous year's question paper and CBSE sample papers. Let's get started for today. The first question is, if alpha and beta are the zeros of 4x square minus x minus 4, then find the quadratic polynomial whose zeros are 1 by 2 alpha and 1 by 2 beta. Now, the given quadratic polynomial is 4x square minus x minus 4. And you are given that alpha and beta are the zeros of this polynomial p of x. If you are given alpha and beta are the zeros of this polynomial, let us calculate the sum of the zeros. Right? Alpha and beta are given as zeros. So alpha plus beta, that is the sum of the zeros, will be, the formula is minus b by a. So from this polynomial, you can take out your coefficients, that is a is nothing but your 4, your b is nothing but the coefficient of x along with the negative sign, along with the sign. So b is nothing but minus 1 and your c is nothing but the constant term, that is minus 4. Okay, so here this is minus 4. So we always compare it with the standard quadratic polynomial ax square plus bx plus c. This is the standard form. So when you compare, what you get? A is 4, b is minus 1 and c is minus 4. Now, what is minus b by a? So minus of b is minus 1. So this minus is the formula's minus. Within bracket you have to write the b, which is minus 1. Divided by, what is a? It is 4. Right? So your sum of the zeros is nothing but 1 by 4. It is your sum of the zeros, s. Now let me tell you what is the product of the zeros. The formula is c by a. So what is c here? C is minus 4 divided by a. A is 4. So it is minus 4 by 4. So you'll get minus 1. Minus 1 is your product of the zeros. Now with this sum and product, can we calculate what is the quadratic polynomial whose zeros will be 1 by 2 alpha and 1 by 2 beta? Suppose you have a quadratic polynomial with these two as zeros, what will be the sum? So, for the required polynomial, whose zeros are given as 1 by 2 alpha and 1 by 2 beta. Now let us calculate the sum. The sum of zeros, right? SOZ, sum of zeros is 1 by 2 alpha plus 1 by 2 beta, right? You take the LCM, so your LCM would be 2 alpha beta. So what will be the first term? So 2 alpha into what will give you 2 alpha beta? It will be beta. So beta into 1 is beta. So beta plus again 2 beta into what will give you 2 alpha beta? It is alpha. So alpha multiplied by 1 will give you alpha, right? Alpha plus beta. What is alpha plus beta? From our given polynomial, what is your alpha plus beta? It is 1 by 4. So I'm just going to write 1 by 4 divided by 2 multiplied by what is your alpha beta value? Minus 1. So minus 1. So this will be nothing but you'll be getting 1 divided by 4 into 2 into minus 1. So it is 1 by 4 multiplied by minus 2, which is minus 1 by 8. This is the new sum of zeros for the required polynomial. For the required polynomial, the sum of the zero is minus 1 by 8. Okay. Now let us calculate the product of the zeros. 1 by product of the zeros. 1 by 2 alpha multiplied by 1 by 2 beta. What is the product? It will be 1 divided by 4, 2 into 2, 4, alpha into beta is alpha beta. So 1 divided by 4 into what is alpha beta value? Alpha into beta is minus 1. So 4 into minus 1, which will be minus 1 by 4. Now, you know the sum of the zeros of the new polynomial and you know the product of the zeros. So let us go ahead and find our new required polynomial. So the required polynomial will be the required quadratic polynomial formula will be, if you know the sum and the product of zeros, okay, sum of zeros and product of zeros, the formula is k multiplied by x square minus sum of the zeros into x plus the product of the zeros. So k multiplied by x square minus, what is the sum of the zero? Minus 1 by 8 into x plus p is nothing but minus 1 by 4. Okay. You can either leave it like this or you can take the LCM of 8. Okay. So you can either leave it like this, or if you take LCM 8 whole divided by 8, you will have 8x square. Minus into minus is plus x minus 2. Right. So this is what will be your polynomial. And if when k is equal to 8, right, you will have 8 by 8, which is 1. So the required polynomial will be 8x square plus x minus 2 will be your required polynomial. Okay, so that's your answer. Please make sure you do these, you actually solve this question yourself and then verify your answer. Okay, so this is that required polynomial whose zeros will be 1 by 2 alpha and 1 by 2 beta. Okay. So from the given polynomial, we are finding out what is the sum of the zero and what is the product of the zero. So we are finding out the sum and product, and using these values for the required polynomial, we are calculating the sum of the zeros using those values, right? Using the existing values, we are finding out the sum and the new product, and using these sum and product, we are creating or writing our required quadratic polynomial. Okay, hope you understood. Let's move on to the next question. If alpha and beta are zeros of the polynomial p of x equal to x square minus 2x minus 1, find the value of 1 by 2 alpha plus 1 by 2 beta plus 3 alpha beta. A very similar question. So your given p of x is nothing but polynomial is x square minus 2x minus 1. What is your a here? A is 1, b is nothing but the coefficient of x which is minus 2 and c is nothing but minus 1. Sum of the 0, that is alpha beta, equal to minus b by a, which will be minus is the formula's minus and then b is minus 2. So minus 2 by a is 1. So the answer is 2. Product of the 0 alpha beta equal to c by a. What is c? Minus 1. A is 1. So it is minus 1. Using these two values, let us find the value for 1 by 2 alpha plus 1 by 2 beta plus. Okay, so therefore 1 by 2 alpha plus 1 by 2 beta plus your 3 alpha beta. We have to find the value. So if you take the LCM, you will have 2 alpha beta. So here again 2 alpha into what will give you 2 alpha beta? It will be beta. Beta into 1 is beta plus 2 beta into what will give you 2 alpha beta? It's alpha. So alpha multiplied by 1 is again alpha plus here it is divided by 1. So 1 into what will give you 2 alpha beta? It's 2 alpha beta. So that 2 alpha beta into 3 alpha beta. So 2 into 3 is 6. Alpha beta into alpha beta is nothing but, let me write it the same way, alpha beta into alpha beta. So everything is of the form alpha plus beta and alpha beta. So alpha plus beta is what? Plus 2. So let's substitute the value. Alpha plus beta is 2. So here you will get alpha plus beta is 2 plus 6 multiplied by alpha beta is minus 1 into minus 1 whole divided by 2 into minus 1. Right? So minus into minus is plus. So it's nothing but 2 plus 6, which is 8 divided by minus 2. So 2 4s are 8. The answer is minus 4. Okay, so what is the value? This is your answer. The value of this entire 1 by 2 alpha plus 1 by 2 beta plus 3 alpha beta is nothing but minus 4. Okay, very, very easy problem. From the given polynomial, just find the sum of the zeros and product of the zeros. So using that, you will be able to evaluate. Let us move on to the next question. Please make sure you pause the video and do it along with me. Only then, if such similar questions come in the exams, you will be able to do it confidently and without any mistakes. Okay. Let's move on to the third question of the day. If alpha and beta are the zeros of the polynomial, you are given a polynomial, you have to find the value of alpha to the power 4 beta cube plus alpha cube beta to the power 4. Let us write the given polynomial. P of y equal to y square minus 5y plus 3. This is the given polynomial. Same way, let us calculate what is a. A is the coefficients. These are called the coefficients. What are the coefficients? A is 1, your b is minus 5 and your c is going to be 3. Let's calculate the sum of the zeros. The formula is minus b by a. So minus of minus 5 by 1, which is nothing but your sum is plus 5. The product of the 0 alpha into beta is nothing but the formula is c by a. What is your c? 3. A is 1. So it is just 3. What you have to find? You have to find the value of alpha to the power 4 beta cube plus alpha cube into beta to the power 4. Okay, what is common? I can take alpha cube, beta cube common. So you'll have alpha plus beta left over. Okay, this is nothing but I can write alpha cube, beta cube as alpha plus beta the whole cube multiplied by alpha plus beta. So I have to always make sure I have it in the form of sum of zeros and product of zeros. So what is the product of 0? Alpha beta is 3. So 3 cube. Okay, so alpha beta is 3 and alpha plus beta is 5 into 5. So 3 3s are 9, 3s are 27 multiplied by 5. So 5 7s are 35, 5 3, 135 is the correct answer. Right? 27 into 5 is 135. I hope you are able to understand now that, we are doing the same kind of problems. Let us do one more question of the similar kind. Yes. Again, if alpha and beta are zeros of the given polynomial, then find the value of alpha plus alpha beta. Here already you have sum and product. So you don't have to do anything much. Let us do it. So your given p of x is nothing but 5x square minus 6x plus 1. Your a is nothing but 5. Your b is minus 6. And your c is nothing but 1. So the sum of the 0 alpha plus beta equal to minus b by a. Minus of minus 6 by 5, which is 6 by 5. Minus into minus is plus. The product of the 0 alpha beta equal to c by a. What is c? 1. 1 by a is 5. Okay, so 1 by 5. Now you have to find the value of alpha plus beta plus alpha beta. What is alpha plus beta? It is 6 by 5. So 6 by 5 plus what is your alpha into beta? It is 1 by 5. Your LCM is 5. Numerator will be 6 plus 1, which is nothing but 7 by 5. And that is your answer. Okay. So this is your final answer. That's all. So it's so easy. Given the polynomial, quickly get the sum of the zeros and your product of the zeros. And using this, you will be able to find the given value, whatever is asked. Okay. So the answer is 7 by 5. Let us do one more question as a part of today's daily practice. And I will be connecting with you every Sunday at 6 p.m. in my channel Numeriq Learning. And we will be solving important MCQs of polynomials and each chapter every Sunday for 1 hour, 6 to 7 p.m. IST. Do join and let us solve MCQ questions. Okay. So this is the last question of today. If one of the 0 of the polynomial, you are given a polynomial, p of x, is the reciprocal of the other, then find the value of k. What do you mean by reciprocal? But before that, let us write what is the given polynomial. P of x is 6x square plus 37x minus k minus 2. So your a is 6, b is 37 and your c, always make sure you write it along with the sign, minus k minus 2. Always make sure you write this is your c, this is your b and this is your a. Okay, always make sure you write the sign. Now, let us, here it is a little different. So let one 0 of the polynomial be alpha. So the other, what is it given? If 1 0 is the reciprocal of the other. What do you mean by reciprocal? Reciprocal means if one is alpha, the other one is 1 by alpha. Okay. You have to find the value of k. See, alpha plus beta, the sum of 0 is minus b by a. But you don't have your k term in b or a. So let us directly calculate the product. So product of 0 is nothing but what you see? The product of the zeros, your product of the zeros, alpha into beta is c by a, right? We know alpha into beta is equal to c by a. But in our case, one of the alpha is just alpha. The other 0 is 1 by alpha. So this is your product is equal to c by a. What is c? Minus k minus 2 divided by 6, right? So alpha gets cancelled, cross multiply. So 6 is equal to minus k, open the brackets, plus 2. So k will go here. It's equal to 2 minus 6. That is minus 4. So k value is minus 4. Okay. So always remember such questions are very frequently asked. These kind of questions are the ones which you have to repeatedly practice and revise. Welcome to day 13 of Do Math with me. Today we will be solving some 5 problems from the chapter Polynomials. So please take your notebook and do this problem with me. Pause the video, write the question, and let's do it together. The first question for the day is, if the product of the zeros of p of x, quadratic polynomial p of x, is equal to ax square minus 6x minus 6 is 4. You are given the product of the zeros of this polynomial is 4. Then find the value of a. Okay, the minute you see such questions, the very first thing that you have to do is write your given polynomial p of x. So p of x is equal to ax square minus 6x minus 6, right? So let your alpha and beta be the zeros. Let's find out the sum of the zeros. Alpha plus beta is equal to minus b by a. So minus of b is minus 6. A is nothing but just a, right? So here I will write minus of minus 6 by a. Okay, and your product of the zeros, alpha multiplied by beta, alpha beta equal to c by a. C is minus 6 by a. Okay, now using these two we can find the value of a. But what are we given? We are given only the product of the zeros. Okay, we are given the product of the zeros is 4. So just equate it. So what is the product of the zero? Alpha beta is equal to, you are given it as, the value is 4. This is given to you in the question. So what is alpha into beta? Minus 6 by a is equal to 4, or you can get right 4a is equal to minus 6, or a is equal to minus 6 by 4. So 2 2s are 4, 2 3s are again. So what is the value of a? A is nothing but minus 3 by 2. That's your answer. Okay. So the value of a is nothing but minus 3 by 2. A very easy question. Okay. Whenever you are getting the polynomials, find the sum and the product of the zeros. Sum of the zero is minus b by a, product of the zero is c by a. Right? I hope you understood. Very easy problem. Let's move on to the next question. So the next question is, if alpha and beta are the zeros of p of x, which is given 4x square minus 5x minus 1, find the value of alpha square beta plus alpha beta square. The first thing to do is write your p of x polynomial, quadratic polynomial, 4x square minus 5x minus 1. So you are given alpha and beta are the zeros. The first thing to do is calculate the sum of the zeros. Minus b by a is the formula. So minus of minus b is minus, your b is nothing but minus 5, by a is 4. So 5 by 4 is your sum of the zeros. And then calculate the product of the zeros. Formula is c by a. What is your c? Your c is minus 1, a is 4. So minus 1 by 4. Now what you have to find? To find alpha square beta plus alpha into beta square. Take alpha beta common. So what do you have? Alpha plus beta remains. What is alpha beta? Minus 1 by 4 multiplied by, what is alpha plus beta? The sum of the zero, 5 by 4. So what is this value? Minus 5 by 4 into 4, 16. This is your answer. Okay. Always make sure you write the question followed by the answer, and write it very clearly, neatly. Okay. Only then it will be easier for whoever is correcting, your teachers, whoever are correcting your question paper or your answer script, they will find it very easy to evaluate. If you write all of these formulas, please do not skip writing the formula. Okay, sum of the zero is minus b by a, product of the zero is c by a. And then what you have to find is this expression. So from here you can take alpha beta common out, alpha plus beta. So whatever is asked, you have to make sure you are converting entire expression in the form of alpha plus beta and alpha beta, so that it's easier for you to substitute the value, because only those two are the values which you know. I hope you understood. Let us move on to the next question.
Find the value for which one root of the quadratic equation px square minus 14x plus 8 equal to 0 is 6 times the other. As usual, the minute you have your quadratic equation, let's write it again. Px square minus 14x plus 8 is equal to 0. Let the two roots be alpha and beta. Okay, so the first thing is calculate the sum of the roots. Minus b by a. So minus, formula b is nothing but minus 14 by a is nothing but your p. So it's nothing but 14 by p. This is your sum of the zeros, so sum of roots. Product of the roots is nothing but c by a. What is your c in the given question? C is 8. A is p. Okay, so 8 by p. Now let one root, what is given is find the value for which one root of this equation is 6 times the other. So let your one root be alpha, then the other root will be 6 times alpha, then the other root will be 6 alpha. Okay, now for this you have to find the value, right? We have to find the value of p for which, okay, so you have to find the value of p. Here you have to find the value of p for which one of the root of the equation is 6 times the other. Now let one root be alpha, the other time is 6 times alpha. So now let's calculate the sum of the roots. That is alpha plus 6 alpha is equal to minus b by a, which is nothing but 14 by p, right? 14 by p. Then 7 alpha is equal to 14 by p, right? Alpha is equal to 14 by 7p. So 7, so this is nothing but 2 by p. Okay. Let us find for the other. Let's find out the product of the roots. So product of the roots will be, the product of the roots will be alpha multiplied by 6 alpha equal to c by a. What is c by a? 8 by p. So 6 alpha square is equal to 8 by p. What is alpha that you have got here? 2 by p. So 6 into alpha square will be 2 by p the whole square equal to 8 by p. Okay. So what do you get here? You will have to solve it. 6 multiplied by 4 by p square, right? 4 by p square is equal to 8 by p. Let me do it here. So you will have 24, and I'm doing it here, okay? So 24 by p square is equal to 8 by p, right? So cross multiply, you will be getting 24p, okay, is equal to or minus 8p square is equal to 0. Take 8p common out, so you will have 3 minus p equal to 0. Am I right? So either 8p equal to 0 or 3 minus p equal to 0. So p is equal to 3. This is one of the value, and the other value will be p equal to 0. Okay, 8p equal to 0 means p is equal to 0. Is it clear? So this or this is the answer. So find the value of p for which one root of the quadratic equation is 6 times the other. So you will have either p can be 0 or p is equal to 3 is the answer. Please make sure you do this question. So these are the kinds of questions which you have to practice. Okay. Pause the video, do it, do everything step by step. The next question, let's move on to the next. If one zero of the quadratic polynomial f of x equal to 4x square minus 8kx minus 9 is negative of the other, then find the value of k. Let us write what is the given polynomial f of x first. 4x square minus 8kx minus 9. Okay, so here you know a is nothing but 4, b is minus 8k. Okay, A is nothing but 4, B is nothing but minus 8k, and your C is nothing but minus 9. Get me the sum of the zeros. Alpha plus beta is equal to minus B by A, which is minus of minus 8k by 4, which is minus into minus plus 8k by 4, which is 2k. Right? Product of the zeros, C by A. So minus 9 by 4. 1, you are given that 1 0 is negative of the other. That means let 1 0 be alpha. Let 1 0 be alpha. Then the other 0 will be. Then the other 0 will be minus alpha. Negative, right? Minus alpha. Now let us calculate the sum. Then the sum of the zeros will be alpha plus minus alpha is equal to minus b by a. What is minus b by a? 2k, right? So alpha minus alpha is 0 is equal to 2k, or you get k is equal to 0. Okay, so this is your answer. Why am I not going to take product? Because product does not have k at all in it. Okay, so you are only asked to find the value of k, and k is involved in the sum of the zeros. So we are just calculating the sum. So k is equal to 0 is the answer. Okay, let's move on to the next question. If alpha and beta are the zeros of p of x equal to, you are given a quadratic polynomial x square minus ax minus b, find the value of alpha square plus beta square. Let's write what is given first of all. So p of x is nothing but x square minus ax minus b is the given polynomial, and you are given alpha and beta are the zeros. So the minute before you even get into what you have to find, let us find the sum of the zeros. So alpha plus beta equal to minus b by a, which is minus of minus a by 1, which is nothing but just a. Then product of the zeros, c by a. What is c? Minus b by 1, which is minus b. Now let us see what you have to find. You have to find alpha square plus beta square. How will you find out? You should know a formula, which is alpha plus beta the whole square is equal to a plus b the whole square is equal to a square plus b square plus 2ab, right? So what will be the value of alpha square plus beta square? Will be equal to, this value will be equal to alpha plus beta the whole square minus 2 alpha beta together. Okay, so this will be equal to alpha plus beta the whole square minus 2 alpha beta. So this is a very important identity which you have to remember. Okay, it is used multiple times. It will be used very frequently this year for you, so please remember it. So let's write it directly. Alpha square plus beta square will be equal to alpha plus beta the whole square minus 2 alpha beta. So what is alpha plus beta? It is a square minus 2 into what is alpha beta? Minus b. Okay, so you are getting a square minus into minus is plus 2b. That's your answer. So in order to do this question, you have to remember this formula. Alpha square plus beta square equal to alpha plus beta the whole square minus 2 alpha beta. So hope you understood. These are five different types of questions which we solved today, and all of them were of similar kind. The minute you are given polynomial, you have to understand what condition is given, whether 1 0 is negative of the other, or 1 0 is square of the other, or 1 0 is 6 times the other. So based on, or if you have to find the value of any given expression, you will have to solve it accordingly. But the minute you have your polynomial, get the sum and the product, and then proceed accordingly. Okay, so I hope you understood and you have done all of these questions. If you like this video and if you are able to understand what I'm trying to teach, please do consider writing a comment below. It will be very, very encouraging and motivating.
And if you have any doubts, please post those doubts in the comments. I'll definitely reply to them and I'll make sure that I clarify them in the next video. Let's get started today. The first question is, find a quadratic polynomial. Find a quadratic polynomial. You have to find a quadratic polynomial, each with the given numbers as the sum and product of its zeros respectively. Let me tell you what is a quadratic polynomial. Okay, so a quadratic polynomial in general is of the form ax square plus bx plus c. This is the standard form of any quadratic polynomial. The highest power of x here is 2, so the degree is always 2, and because the degree is 2, this is called a quadratic polynomial. And let us denote it with p of x, that means polynomial with variable x. Now these a, b and c are called the coefficients. What is a? A is the coefficient of x square, plus b, b is the coefficient of x, and c is the constant. In general, a, b and c are all called the coefficients. Okay, the coefficients are a, b and c. Now, because the degree is 2 and because it is called a quadratic polynomial, this particular polynomial can have maximum 2 zeros. What do you mean by zeros? Zeros means that specific value of x which when substituted will make this entire polynomial value as 0. Okay, so there can be a maximum of 2 zeros. That means 0 means 2 values of x, maximum 2 values of x that can make this particular polynomial value to be 0. There can be 1 0 and there can be no zeros also. So let us assume that this particular polynomial has got 2 zeros, namely alpha and beta. Okay, what is alpha and beta? Alpha and beta is that value of x which can make p of x 0. Okay, when you substitute alpha value, alpha could be some integer value. When you substitute that value of x, right, in place of x, if you substitute, your p of x will become 0. That is why alpha is called the 0 of the polynomial. Same with beta, and this alpha and beta can be any value, right? So always remember, quadratic polynomials can have a maximum of 2 zeros, mostly denoted by alpha and beta. Okay, now there is an important formula which you should know. If you are given that alpha and beta are the zeros of a quadratic polynomial p of x, and that p of x is of the form ax square plus bx plus c, then there is a formula that you have to remember. One is sum of the zeros. The formula is alpha plus beta is equal to the sum of the zeros, right? Should be equal to minus b by a. This is the formula. And the product of the zeros this is denoted by s, and let me denote this by p. Alpha into beta is equal to, a product of alpha beta is equal to c by a, right? So if you know the alpha and beta values, you can calculate the sum and you can find out the product, right? Now if you know the sum and the product of, okay, if you know the sum and product, that is s and p, you can write a quadratic equation, or you can write a quadratic polynomial using again another formula, which is nothing but k multiplied by x square minus sum of the zeros into x plus the product of the zeros. Okay, and this k can be any value, it can be 1, 2, 3, anything. So this is a formula which you should remember. The first one is, you should know
the standard form of a quadratic polynomial is ax square plus bx plus c, where a, b and c are the coefficients. Normally, a polynomial with variable x is denoted by p of x. The degree of a quadratic polynomial is the highest power of x. That is what is called the degree, and for a quadratic polynomial, the degree is 2. A, b and c are the coefficients. Any quadratic polynomial can have a maximum of 2 zeros. It can have 1 zero and it can have no zeros also, but it can never go beyond 2. At most, maximum it will have 2 zeros. What do you mean by 0? 0 means that value of x which will make p of x 0. Let us assume that alpha and beta are the zeros of this polynomial. Alpha and beta could be some value. Okay. Now, if you know alpha and beta of some polynomial p of x, what can you calculate? You can find immediately the minute you are given a polynomial, you can find out the sum of the zeros. How will you find out the sum of the zeros? Using this formula, that is alpha plus beta is equal to minus b by a. B and a are the coefficients. You can find out the product of the zeros, c by a. Suppose you are given the sum and product directly, you can just substitute it in the formula, which is k multiplied by x square minus sx plus p, where s is the sum of 0, p is the product of 0. Mainly this much is the only thing, the main thing that is needed for your chapter 2 polynomials, mainly, predominantly. If you are asked the relationship between the coefficients and the zeros, these are the two things which are very important, wherein you are able to relate the zeros with the coefficient. You are able to relate the zeros with the coefficient. Alpha and beta are the zeros. B, A, C, A are the coefficients. So, how will, tell me the formula to relate the zeros and the coefficients means you will tell these two. Okay, alpha plus beta is equal to minus b by a, alpha beta is equal to c by a. Now, in our given question, let's get back to the question. I hope you understood this. This is just theoretical, but this knowledge is needed for solving today's question. Find a quadratic polynomial. You have to find a quadratic polynomial, each with the given numbers as sum and product of its zeros. As I told you, this value, sum of the 0 is given to you, product of the 0 is given to you. So, let us do it. So, this is the sum and this is the product. Okay. If you know the sum and the product, if you know the s value and p value, sum and the product of the zeros, you just have to substitute it in this formula. This is the quadratic polynomial. Okay, so if you know the sum and product of the zeros of any polynomial, you will be able to write the quadratic polynomial. How? Using the formula k multiplied by x square minus sx plus p. So, k multiplied by x square minus s is nothing but 1 by 4x plus p. So, plus of minus 1. Be very careful. Okay. So, let me write this k multiplied by x square minus 1 by 4x minus 1. Right? You can take an LCM. So, when you take LCM, what will you have? 4 in the denominator. So, here you will have 4x square minus x minus 4. K is outside. Okay. K you can, the denominator 4 you can take it out. So, you can write k by 4, or you can write when k equal to 4. When k is 4, what will happen? If k is 4, 4 and 4 will get cancelled. So, what is the quadratic polynomial? 4x square minus x minus 4 is the required quadratic polynomial. That's all. Always write the formula first. Okay, you are given the sum of the zeros, you are given the product of the zeros, you just have to write the formula first. First thing that you have to do is write the formula k multiplied by k is some constant value. And one more thing you have to remember is, for any set of values, right, there can be infinite number of polynomials. This answer is never, it need not be a fixed answer. You can take, this can also be done. You can just leave it like this. Okay, in this step itself, you can take k equal to 1. If k is equal to 1, everything that's within the square bracket is your answer. You can just leave it like that, you will get full marks. If you want, you can take the LCM and then take this divided by 4 outside and take k as, let k be 4. When k is 4, 4 and 4 will get cancelled and this is your answer. So it completely depends on your convenience only. So for a given set of sum and product, you will have infinite number of polynomials. Okay, depending on what value of k you are taking. Now this particular thing you will become more clear as we go ahead with another problem. So again, the next problem is, you can make a note of it, pause it, please make a note of this, and let's go ahead and do the next question. It's the same question. You are given two numbers. One is the sum of the 0, the other one is the product of the 0. You have to find a quadratic polynomial. So the formula is k multiplied by x square minus sum of the zeros into x plus product of the zeros. So k multiplied by x square minus s is nothing but root 2. It's given to us, x plus product is 1 by 3. Let us take the LCM. So when you take the LCM, what will you have? Denominator 3. So numerator will be 3x square minus 3 root 2x plus 1. Right? So k by 3 multiplied by 3x square minus 3 root 2x plus 1. Then when k equal to 3, when I am taking k equal to 3, what will be the polynomial? The required polynomial is 3x. So 3 and 3 will get cancelled. It will become 1, right? 3 by 3 is 1. So 3x square minus 3 root 2x plus 1. This is your final answer. Suppose you take k is 6. Then what will you have? You will have to multiply everything with 2. So you will have 6x square minus 6 root 2x plus 2. This is also correct. This is also correct. Okay. So again, it completely depends on if you are taking k as 9. Okay. If suppose k is 9, what will you have outside? You will have a 3. Multiply 3 with all the terms. That is your final answer. So for any given set of sum and product, you can have infinite number of polynomials. Okay. Depends on what value of k you choose. I hope that is clear. Let's go ahead with the next question. Yeah, the next question is, your sum is 0 and your product is root 5. The first thing to do is write the formula k multiplied by x square minus sx plus p. So k multiplied by x square minus a sum is 0. 0x plus p is root 5. 0x is nothing. You don't have to write anything. So k multiplied by x square plus root 5. Then what value of k do you take? I will take k equal to 1. When k equal to 1, x square plus root 5 is the answer. This is my required polynomial. Right? Okay. So if you solve this, right, the sum, you will get alpha and beta, let it be zeros, and using that alpha and beta, suppose alpha and beta are the zeros of this final polynomial, you will have to find the zeros, and when you take the sum of those zeros and product of the zeros, you will be getting sum as 0 and product as root 5. Okay. Again, if you are taking k as 2, what will be the answer? 2x square plus 2 root 5. That's also right. This is also, any answer is correct. But make sure you write the formula. For writing the formula and then substitute it in the next step and then solve it. Okay. Let's move on to the fourth question. 1 and 1. Okay. So sum of the zeros is 1. Product of the 0 is also 1. So the formula is k multiplied by x square minus sx plus p. This is the formula if we know the sum and product. Let's substitute it. X square minus 1 into x plus 1. Right. So when k is equal to 1, the formula, the quadratic polynomial becomes x square minus x plus 1. Be very careful with the sign in the formula. Okay, x square minus sx plus p. Remember it, write it in a separate notebook or mark it as important, revise it and make sure you remember. Let's move on to the fifth question. Minus 1 by 4 and plus 1 by 4. So one is the sum, the other one is the product. The formula is k multiplied by x square minus sx plus p. So k multiplied by x square minus sum is minus 1 by 4. Okay, this minus is the formula's minus and the sum also has the negative sign. So I am putting it in the bracket. Do x plus product is 1 by 4. Now let's open the bracket. Minus into minus is plus. 1 by 4x plus 1 by 4. Okay. So you have k multiplied by 4x square plus x plus 1 whole divided by 4. I am taking it outside. Okay. I am taking it outside. So now when k is equal to 4, the denominator 4 I took it outside. When k is equal to 4, what will you have? 4 and 4 will get cancelled, it will become 1. So 4x square plus x plus 1 is the required polynomial. Okay. The next question, 4 comma 1. So 4, let it be the sum and 1 is the product. Again, k multiplied by x square minus sx plus p. Okay, so k multiplied by x square minus sum is 4, 4x plus product is 1. When k is equal to 1, the polynomial is x square minus 4x plus 1. That's all is your answer. Right? So if you know the sum of the zeros and if you know the product of the zeros, you will be able to find the quadratic polynomial using this formula. Very, very easy. So in any form, even in case study questions, if you know the sum and product, you will be able to find a quadratic polynomial whose sum and product of the zeros are given. Right? So please remember this, and if you have any doubts, please, again, as I told you, please post it in the comments. And this Sunday, definitely join me in a live YouTube session wherein we will be solving MCQ questions related to polynomials from the chapter Polynomials, only MCQs. And if you have any doubts, you can ask me during the live session. It's from 6 p.m. to 7 p.m. Sunday in our channel Numeriq Learning. Okay, so till then, happy learning, and make sure you are following the series. You can check out the Exemplar exercises, NCERT exercises and all the questions done related to your chapter 1 real numbers and polynomials. Thank you so much, and if you are finding my video helpful, do share with your friends and please do subscribe. Thank you so much. Today we will be solving some 4 important questions from the chapter Polynomials as a continuation of the daily practice series. So please take your notebook and let's do these 4 very, very important problems today. The first question of the day is, if alpha and beta are the zeros of the quadratic polynomial such that alpha plus beta is 24 and alpha minus beta is 8, find a quadratic polynomial having alpha and beta as its zeros. You are given that alpha and beta are the zeros of the quadratic polynomial, and you have to also find that quadratic polynomial whose zeros are the 2 given. But in order to know what is alpha beta, the hint that you are given is you are given the sum and the differences. Okay, so let us go ahead and solve these 2 equations and get the value of alpha and beta separately. So you are given alpha plus beta is nothing but 24. You are also given alpha minus beta is nothing but 8. Just add them. When you add them, beta and minus beta gets cancelled. Alpha plus alpha is 2 alpha is equal to 24 plus 8 is 32. So alpha is equal to 32 divided by 2, which is nothing but 16. Okay, so alpha is nothing but 16. So you have got 1 0 of the given quadratic polynomial. Now let's substitute this alpha in any one of the equation. So for example, alpha minus beta is equal to 8. We know that. So alpha is 16. So 16 minus beta is equal to 8. Or if beta goes to the other side, beta is equal to 16 minus 8. Right? So here what I have done is beta goes to the other side, 8 comes here. So 16 minus 8 minus beta, when it goes to the other side, it becomes plus beta. Okay. So what is 16 minus 8? It is just 8. So this is the other 0 of the quadratic polynomial. Now if you know the zeros, how will you find? If you just know the zeros, you will not be able to find or write a quadratic polynomial. In order to write a quadratic polynomial, you need to know the sum of the zeros. Sum of the zeros. Because the formula for writing the quadratic polynomial is k multiplied by x square minus sx plus p, where s is nothing but your sum of zeros and your p is nothing but the product of the zeros. So if you know the zeros, you can easily write the quadratic polynomial by calculating first its sum. So alpha plus beta. What is alpha? 16 plus beta is 8. So it is 24. Your 24 is nothing but your sum. Now product of the zeros. What is the product of the zeros? Alpha into beta is equal to 16 multiplied by 8. So 8 6 are 48 and 12 128. Now how will you write the quadratic polynomial? K multiplied by x square minus the sum of the zeros into x plus the product of the zeros, right? So k multiplied by x square minus the sum is 24, 24x plus 128. Right, this is your quadratic polynomial. Or default, when k is equal to 1, the polynomial is x square minus 24x plus 128. This is your required polynomial, which has got both alpha and beta as their zeros. Okay, so this is your final answer. I hope you understood. So in order to do this question, the very first thing that you have to know is you should know to correctly solve this pair of linear equation. These two are linear equation. You should solve it, right? You're adding them. Why? Because in one of the equation you have a plus beta. The other equation you have a minus beta. So if you just add them, what will happen? Alpha plus beta plus alpha minus beta. Just add the RHS and LHS. 24 plus 8. This also you can do. Beta gets cancelled. So 2 alpha equal to 32. Alpha. So it's the same thing, right? If you're just adding both these LHS and RHS together, also it's fine. And then after you find out the alpha and the beta, so these two are the zeros of the polynomial. Okay, these two are the zeros. In order to find a quadratic polynomial, you should know this formula, which is k multiplied by x square minus sx plus p. S is nothing but the sum of the zeros. P is nothing but product of the zeros. You know the zeros, calculate the sum. Just add them and that value is your sum. Find the product of alpha and 0, that will be a product value. And just substitute it in this formula. Right, k into x square minus sum of zeros into x plus product of the zeros, and there you get your answer. Right, this is the required polynomial. It's a very good question, very easy question to do. I hope you understood. Please pause the video and make sure you are doing it on your own and then verify your answer. Let's move on to the next question. Find a quadratic polynomial whose zeros are negative of the zeros of the polynomial px square plus qx plus r. Okay, so the minute you are given a particular polynomial, right? See, you are given, find a quadratic polynomial whose zeros are negative of the zeros of the polynomial. So let alpha and beta be the zeros of
let your alpha and beta be the zeros of your given polynomial, that is px square plus qx plus r. Okay. The zeros of the required polynomial will be negative of these zeros, right? So the zeros of the required polynomial will be, what is it given? Find whose zeros are negative of the zeros of the polynomial. So they are negative of alpha and beta. So minus alpha and minus beta, right? So now for the given polynomial, that is for px square plus qx plus r, what is the sum of the zeros? Calculate the sum of the zeros. Alpha plus beta equal to minus b by a, which is minus q by p. The product of the zero, the formula is c by a, which is nothing but r by p. So we know this formula, which is related to a relationship between, you're relating your zeros with the coefficient, right? Your sum of the zeros is equal to minus b by a. Your product of the zeros will be equal to c by a. This is the relationship between the zeros and the coefficients of any quadratic polynomial. Okay. So once you have got for the given polynomial, this px square, this is the given polynomial, what they have given us, what the question is giving us. For this polynomial, you are assuming alpha and beta are the zeros. And because you have we have already taken alpha and beta as zeros, we have calculated the sum and the product. Now, the required polynomial, the zeros would be minus alpha and minus beta. Now, let us write the required polynomial. Okay. The required polynomial, the formula is k multiplied by x square minus sx plus p. Okay. So, for this required polynomial, k multiplied by x square minus, in a square bracket, what is the sum of the zero? Sum of zeros. So, for the required polynomial, the zeros are minus alpha and minus beta. So, minus alpha plus minus beta. This is the sum of the zeros into x plus the product of the zeros. Minus alpha into minus beta. Product of the zeros. Okay. So, here it is k multiplied by x square minus. Take, this is nothing but minus alpha minus beta. Take minus common out. You will have alpha plus beta. Multiplied by x. Minus into minus is plus. So, plus alpha beta. Okay, minus into minus is again k multiplied by x square plus, okay, alpha plus beta into x plus alpha beta. We know the sum and the product, right? Sum is nothing but minus, what is alpha plus beta value? Minus q by p. Alpha beta value is r by p. Let's substitute it here. So you get k multiplied by x square plus minus q by p into x plus r by p. Plus r by p. Okay. So take p as LCM. So what will you get? I'm taking that p outside. Okay. Or I'll probably take it in the next step. So whole divided by p is the LCM. So you have px square minus qx plus r. Am I right? So you can take p outside. So you'll have k by p multiplied by px square minus qx plus r. So this is the required polynomial when the zeros are negative of the given. So the required polynomial, the zeros are negative of the zeros of the given polynomial. Is it clear? So the minute you are given a polynomial, quickly find out the sum and the product using this formula, that is alpha plus beta equal to minus b by a, alpha beta equal to c by a. This is for the given polynomial. Keep these values separate. Now, what is the question asking? You have to find the quadratic polynomial whose zeros are negative of the zeros of the given. So, if the zeros of the given polynomial are alpha and beta, the required polynomial zeros will be negative of alpha and beta, that is minus alpha minus beta. Now, for these two zeros, you have to write the equation, that is required polynomial is k into x square minus sx plus b. Just replace the sum with the zeros minus alpha and beta, the product also, and then finally when you have everything of the form alpha plus beta and alpha beta, then replace the values, that is minus q by p and r by p, and then solve it and you will be getting the required polynomial. Now this required polynomial has the zeros minus alpha and minus beta. Okay, minus alpha and minus beta. This is your final answer. I hope it is clear. Now let's move on to the next question. If the square difference of the zeros of the quadratic polynomial f of x equal to x square plus px plus 45 is equal to 144, find p. Again, a very easy question. So what are you given? You are given your polynomial. So the minute you have your polynomial f of x equal to x square plus px plus 45, get the sum of the zeros alpha plus beta equal to minus b by a. What is b? P. So minus p by 1, which is just minus p. What is alpha beta? C by a. Write the formula always. So 45 by 1, which is nothing but 45. Now, if the squared difference of the 0, what is the difference of the 0? Alpha minus beta. Square difference means square of that. The square difference of the zeros of this particular, the square difference of the zeros of the quadratic polynomial. So here you have alpha and beta are the zeros. The value is equal to, see, the square difference of the zeros of the quadratic polynomial is equal to 144. So this is equal to 144. What is alpha minus a minus b the whole square? A square plus b square, that is alpha square plus beta square minus 2 alpha beta is equal to 144. What is this alpha square plus beta square? Remember the identity. Alpha plus beta the whole square is equal to, that is a plus b the whole square equal to alpha square a square plus b square plus 2ab. Instead of ab, I am writing alpha beta. Therefore, what will be your alpha square plus beta square will be equal to, take this plus 2 alpha beta to the other end. So what will you get? Alpha square plus beta square equal to alpha plus beta the whole square minus 2 alpha beta. Okay. Now replace it here. Okay. So let this be 1. Let this be 2. So use 2 in equation 1. So what does it become? Alpha plus beta the whole square minus 2 alpha beta. Okay. This is what is the expansion for alpha square plus beta square. Remember, alpha square plus beta square equal to alpha plus beta the whole square minus 2 alpha beta. Then write this minus 2 alpha beta as it is. Minus 2 alpha beta is equal to 144. What is alpha plus beta the whole square? That is minus p the whole square. So what is, okay, so minus p, alpha plus beta, the value is minus p. So minus p the whole square, minus 2 alpha beta, minus 2 alpha beta. So minus 4 into what is alpha beta? 45. Okay, so here I have just solved these two and directly written minus 2 alpha beta, minus 2. So it is minus 4 alpha beta, right? Instead of alpha beta, I have written 45 is equal to 144. So p square minus this will be 180 is equal to 144. Therefore, your p square equal to 144 plus 180, which will be 324. So p is equal to plus or minus root of 324, which is nothing but plus or minus, it is 18. So you're asked to find the values of p. So the possible values of p are, you have to write at the end. Therefore, the possible values of p are, one is plus 18 and the other one is minus 18. This is your final answer. Okay, so always whenever you have a square root, you should always write it in terms of plus and minus. Please do this problem and see. Okay, but in order to do this problem, this formula is very important. You have to learn this problem, that this identity, that is alpha square plus beta square equal to alpha plus beta the whole square minus 2 alpha beta. Okay, this is very important. Only then can you replace this alpha square plus beta square with this formula. That is, the identity is alpha plus beta the whole square minus 2 alpha beta. So this identity is extremely important. Only then will you be able to replace everything that is needed in terms of alpha plus beta and alpha beta, because these are the only two values that you know. So we have written everything in terms of, we have converted everything in terms of sum of the zeros, product of the zeros, so that you can substitute the value and find out the unknown term, that is your P. Let's do the last question of the day. Okay. If alpha and beta are the zeros of the quadratic polynomial f of x, so the minute you get your polynomial, immediately find out the sum of the zero and the product of the zero. You have to prove some expression, LHS equal to RHS. First of all, let us write the given polynomial, that is x square minus px plus q is the given polynomial. Immediately first write the sum of the zeros. Alpha plus beta is equal to minus b by a. That is equal to minus of b is nothing but minus p by 1, which is nothing but just p. The product of the zeros alpha beta is equal to c by a. C is q, a is 1, which is just q. Okay. Let us take the LHS part, the left hand side part. When you solve, you will be getting the RHS. Let us take the LHS, nothing else. From the given polynomial, you have found out the sum of the zeros using the formula alpha plus beta equal to your minus b by a. See the previous DPPs. Okay, so this series is a part of Do Math with Me, and we have been doing a lot of problems every day for 20 minutes, approximately 20 to 25 minutes, or even less than that, for the past 13 to 14 days. So please make sure you are seeing that recording. Take your time. Go through at least 2 old DPPs if you haven't. If you are new to this video, please make sure you complete it, and then you will be seeing a continuity, because if you had seen yesterday's and day before yesterday's, this will be easier for you. That is, whenever you're given a polynomial, a quadratic polynomial, you have to know this particular relationship between the zeros and the coefficients. Alpha plus beta equal to minus b by a. Product of the coefficients is equal to c by a. Now let us write the LHS part of what we have to prove. That is your alpha square by beta square plus beta square by alpha square. Okay. So when you take the LCM, what will you have? Alpha square, beta square is the LCM. So in the numerator, you will have, see, beta square multiplied by what will give you alpha square, beta square? It will be alpha square. This alpha square, multiply it with the numerator. So you will be getting alpha to the power 4 plus, same way, alpha square multiplied by what will give you alpha square, beta square? It will be beta square. This term you have to multiply it with the numerator. So it is beta to the power 4. Right? Now, let us write a relationship, something that we just learned. We just now learned in the previous question that alpha square plus beta square is equal to alpha plus beta the whole square minus 2 alpha beta. I can write alpha to the power 4 as alpha square. Let me rewrite it. Alpha to the power 4 plus beta to the power 4. I can write it as alpha square the whole square plus beta square the whole square. Okay. Now, in place of alpha, I have got alpha square. In place of beta, I have got beta square. So, replace alpha with alpha square, beta with beta square in this particular identity. So, it will be alpha square plus beta square the whole square minus 2 alpha square beta square. Is it correct? Now, this is the formula for alpha to the power 4, beta to the power 4. So, let's replace this here in this above one. Okay, so you will be getting, the numerator will be, instead of alpha to the power 4 plus beta to the power 4, I am going to write alpha square plus beta square the whole square minus 2 alpha beta the whole square divided by, the denominator will also become alpha square beta square. I can write it as alpha beta the whole square. Now this again, this term we don't know, that this term, right? Alpha square beta square we don't know. All we know is alpha plus beta, sum of zeros and product of the zeros we know. So let us apply this identity here. See, alpha square plus beta square is the one which is within the square. So replace it with the identity, which is alpha plus beta the whole square minus 2 alpha beta, again the whole square, minus everything else remains the same. 2 alpha beta, 2 into alpha beta the whole square divided by alpha beta the whole square. Now see, everything we have, every term in the numerator is converted in either in terms of sum, product, product, product. Now let us replace the value. What is alpha beta? What is alpha plus beta? It's p. So p square minus 2. What is alpha beta value? Look here. What is alpha beta? See, sum is p, product is q. Okay. So the product is q. The whole square minus 2q square divided by q square. Okay. Now open the bracket. What is it? This is of the form a minus b the whole square. What is a minus b the whole square? A minus b the whole square is equal to a square plus b square minus 2ab is the identity. So let's replace it. Okay, let's use that identity here. So p square the whole square, a square. A itself is p square. So a square will be p square the whole square, which is p to the power 4, plus 2q the whole square, 4q square, minus 2 into p square into 2q. Be very careful with the sign. Okay, minus 2q square whole divided by q square. Okay, write it every step. Please write it carefully. So you have p to the power 4 plus 4q square minus 4p square q minus 2q square divided by q. So I'm just following it. Okay, now this is a like term, right? These two are like terms. So just combine them. So what will you get? P to the power 4 plus, what is 4q square minus 2q square? It's 2q square minus 4p square q divided by, the denominator is q square. Now just split it up. Okay, split the q square among the three terms. So you have p to the power 4 divided by q square plus 2q square divided by q square minus 4p square q divided by q square. Okay, so q square will get cancelled. Here 1q will get cancelled. So what do you get? P to the power 4 divided by q square plus 2 minus 4 p square by q. This should be your RHS. Probably you'll have to rearrange it and write. So we can still rearrange it and write p to the power 4 divided by q square minus 4p square divided by q plus 2 should be equal to your RHS, which is asked in the question. See, p to the power 4 by q square minus 4p square by q plus 2. Yeah, so this is your RHS. Definitely these are the kinds of questions which you have to be very, very good at. Okay, so this is equal to your RHS, hence proved. You have to prove it. So these are the kinds of questions with, even in tomorrow's DPP, I will be doing it. So please make sure you do these questions positively. So this is the kind of practice that you need in your 10th. So this Do Math with Me is exclusively for students like you who are currently in 10th, preparing with a goal to get, 95% or 100% marks in your mathematics exam. So it's a long term, it's a year long hard work. Definitely practice. I'm sure if you practice, pause the video, try, listen to the video once, see every step of the way, and then try it yourself. I'm sure it will be useful. So, and every Sunday, that is tomorrow also, I mean, if you're seeing the recording, today happens to be Saturday, and tomorrow 6 p.m., I'll be coming on YouTube live for 1 hour, 6 to 7 p.m. IST, and we will be having some important MCQ questions for 1 hour, as much as we can during that 1 hour from the chapter Polynomials. So please do not forget, keep a reminder, and definitely do join. You can ask any doubts at that time. Hoping to see you, and let's keep learning. Be motivated, be very confident. Hard work never fails. So just keep solving problems every day, and you will definitely get better at it each day. So happy learning. Thank you. See you all in the next video. Do share, do subscribe.